Dear students, welcome to the first lecture of linear algebra. It is Inayatullah here from Edwards College, Peshawar. In this semester, linear algebra is a branch of mathematics which will be studied in your current semester. So the first thing is to understand that what is linear algebra. So there are many definitions which you will be able to see on the net, but the most precise definition of linear algebra is that is the branch of mathematics. So the branch of mathematics which deals with things. The first thing is system of linear equations. A linear equation is that equation in which the degree, the power of variables is 1. So whenever two or more equations are combined together, that is called the system of linear equations. So this branch of mathematics, I mean linear algebra, is dealing with the system of linear equations, and secondly it deals with matrices, and you have got the knowledge of matrices from your previous classes, and also you have got the knowledge from your previous classes for the system of linear equations. And thirdly, it concerns with vector spaces. That is a bit new for you people. Vector space, it will be studied in this course. And the fourth one is determinants, and you all are familiar with determinants. And the last one is linear transformations. Linear transformation is also a new thing for you people, which will be studied in this course. So let us start your first chapter from the recommended book for you people, and the name of this chapter is Introduction to Vectors. Remember that the chapter name is Introduction to Vectors. So it means that we need to study in this chapter the basic things about vectors, the basic things, not the whole things, the basic things of the vectors. So first of all, we need to know about the vector, and I hope that you people will be aware about the word vector. Vectors are studied in your first year course, mathematics course. Anyways, the first one is, what is a vector? So a vector is actually a physical quantity. That is a physical quantity which exists, which you can see, a physical quantity. A physical quantity which have two things. The first one is magnitude. Magnitude is also called the length, and secondly which has direction. So a physical quantity which has magnitude and direction is called a vector. For example, velocity. So velocity is actually speed in some certain direction, and force, you are applying a force in a certain direction. In a certain direction you are applying a force. So these are the example of vectors. Secondly, we need to denote a vector. So vectors are usually denoted by letters, small letters, capital letters, whatever you want, but small letters are usually used to denote a vector. We put an arrow above that letter, or an arrow below that letter, or sometimes we write the letter in bold face. So these are the three notations to denote a vector. The fourth notation is, you need to put a cap on a letter, but this notation is specially used for unit vector. Anyways, vector will be denoted by any one of these four notations, but mostly in your course we will denote the vector by bold faced element, or we will put an arrow above the letter. And for unit vector we will put a cap above the letter. Now what is a unit vector? Vector having magnitude 1, 1 meter, 1 kilometer, 1 decimeter, 1 millimeter. So a vector which has magnitude 1 is called a unit vector, which is usually denoted by a cap, n cap, v cap, b cap. Put a cap above the letter, that is a unit vector. And the fourth one is we have got 3 axes and 3D space. We have 2D plane, 3D space, 4D space as well, but we will be studying here 2D plane, because 2D will get you people a plane. For example, if you put X and you put Y, you will get this floor, that is XY plane. That is actually a wall. You can consider it a wall, a whiteboard. So that is a plane. So that is 2D plane. Similarly here, this portion is Y and Z plane, because this is made of Y and Z axis. Similarly this plane is called ZX plane, because this is made of all Z's and all X's. Anyways, so we have unit vectors in the direction of x-axis, which is denoted by I, and unit vector in the direction of y-axis is denoted by J. Unit vector in the direction of z-axis is denoted by K. So that is the fourth one. Similarly, position or radius vector is that vector which is drawn from some origin. Origin is that point at which the value of each component is 0. So if we draw a vector from origin to a point in a plane or space, so that vector is called the position vector or radius vector of that point. For example, if you look at this 2D plane, this plane is made of x-axis and y-axis. Here is a point P, that is point P, and we have drawn a vector from this origin to that P. So this OP vector is the position vector, because it shows the position of P in this plane. So that is called the position vector of this P. And if you rotate this vector, you will get a circle, and this OP will be the radius of that circle. So that's why this vector is also called radius vector. So that is a position vector which is drawn from the origin to a point in a plane or space. Now what is a two-dimensional vector? I mean 2D vector. 2D vector, you see here, if here is a point in the xy plane, so for this point P, the x component is along x-axis from here up to there, and the second component y will be from here up to there, or you may say that from here up to there, that is parallel to this P. So this P, this OP vector is the position vector of this P. You see that I is a unit vector in the direction of x-axis whose magnitude is 1, and J is a unit vector in the direction of y-axis whose magnitude is 1. So this x, the component of this x will be denoted by x into unit vector in the direction of x-axis, and this component, which is the second component y, that is in the direction of y-axis. So this second component will be y into unit vector in the direction of y-axis. So by head to tail rule, this OP vector will be the sum of the first component and second component of this vector. This is the x component of that vector, and this is the y-th component of that vector. So OP will be the sum of these two components. So 2D vector will be denoted by x component into I plus y component into j, in this fashion. Now what is a 2D vector representation? From the last figure, we know that OP vector is the x component of the vector into I plus y component into j. This OP vector can be written in this fashion, and the second style of writing of this vector is the ordered pair form. You should write the x component without I and the y-th component without j, and enclose them in square brackets or in parentheses. So that is the second notation to denote this vector. This vector can also be written in the form of a column vector. The column, in one column, the first component is the x component and the second component is the y-th component. So these three are the notations for a vector in 2D plane. Similarly, this representation can be extended to 3D vector as well. In 3D vector, the third component will be added, that is the z component, along with the unit vector in the direction of z-axis. So that is the first style of writing a 3D vector, and this is the second style of writing this vector, just like that one. Just add the z component, and that is the third style of writing this vector. So all these three have the same meaning. If you write a vector in this fashion, or in this fashion, or in this fashion, all these three have the same meaning. For example, if you are given a vector A like 2i plus 3j plus 5k, so this vector can be written in three ways in this style. How could we write this vector? That is the first style which is given to you. That is the second style. Just write the components 2, 3 and 5 without ijk along with commas, 2, 3, 5. And in column vector notation, this vector can be written as 2, 3, 5 in this fashion, 2, 3, 5. So that is how we write a vector in three styles. Now the next one is addition or subtraction of vectors. What is the addition and subtraction of vector? For example, you are given a vector A whose components are a1, a2, a3. That is, in this vector, this is a1, this is a2, this is a3. So vector A is a1, a2, a3, and second vector whose components are b1, b2, b3. If you want to add these two vectors, a plus b, so just add the corresponding elements, the corresponding components. First component plus first component, second plus second, third plus third. So that is in front of you. If you want to subtract these two, so just subtract these two components, subtract the corresponding components. So that is the addition and subtraction of two vectors. That is, if you want to add or subtract two vectors, you need to add or subtract the corresponding components of both the vectors. And number 9 is scalar multiple of a vector. What does it mean? For example, if you are given a vector A whose components are a1, a2, a3, just like that, and k be any scalar. K is a number, say 2, 3, 5, -2, -3, maybe in fraction 1 by 2, 1 by 3. So that is a scalar. Scalar is actually a non-zero number, non-zero real number. So if you want to multiply this k with this vector, so k times vector will be equal to k times this vector, k times this vector. Then what should we do? We will multiply this k with each of these components. Multiply k with a1, k with a2, k with a3. So that is called the scalar multiple of a vector. Scalar multiple of a vector. So there are two examples. You are given in the first example, you are given two vectors a 3i minus 5j, 3i minus 5j, and a second vector b is minus 2i plus 3j. These two vectors are given to you, and you are asked to find the sum of a and 2b. Secondly, 3a minus 2b, and thirdly 2 times a minus b. And in second question, these two are two-dimensional vectors. You see, there is I and j. So these two are two-dimensional vectors, and here these are three-dimensional vectors. I, j, k are involved here. Similarly, v involved I, j, k. W also involved I, j, and k. So you need to find u minus 2v, u minus 2 times v, 3v plus 2w, 3u minus 2v plus w. So let us start to solve these questions. This vector a can be written in three ways. In your book and your concern book, the vector is written in a column vector notation. I mean, the first component of the vector 3 and the second component minus 5 of this vector a. Similarly, this vector b can be written as minus 2, 3. You see, minus 2, 3. So we have written the same vector, but in the other style, minus 2, 3. Now welcome to this first part. We need to find a plus 2b. So a plus 2b is equal to, write a here, this is a, plus 2b, so that is 2, and b is this vector. Now you see that this vector b is the scalar multiple of 2. So first of all, you need to multiply these two inside with both the components. So that will be 2 2s are 4, 2 3s are 6. Just look at that, minus 4, 6. Now this is the addition of two vectors. How could you add these two vectors? Just add the corresponding components. I mean, first component plus first component. Just look at that. Second component plus second component. Just look at that. Now that is 3 minus 4, which is minus 1, and minus 5 plus 6 is 1. So that is the value for a plus 2b. Secondly, you need to find 3a minus 2b. So 3a minus 2b is equal to 3 into a vector, this a vector, minus 2 into b vector, this is b vector. This a vector is the scalar multiple of 3. So multiply 3 inside with both the numbers. 3 3s are 9, 3 5s are 15, 9 minus 15. Then minus sign is there, and this is the scalar multiple of 2. 2 2s are 4, 2 3s are 6, minus 4, 6. Now these two will be subtracted. How could you subtract these two? Just subtract the corresponding components. First component minus first components. Just look at this. Second component minus second component. Just look at that. Minus minus plus, so 9 plus 4 is 13. Minus 15 minus 6 is minus 21. That is 3a minus 2b. And the third one is you need to find 2 times a minus b. So 2 times a minus b is equal to 2 times this is a minus this is b. First of all, subtract these two vectors in this fashion to get the answer, and multiply the answer with 2 to get this number. So that is 2 times a minus b. So that's how we add, subtract and multiply a vector by a number. So that is the first question. The second question can be solved in the same manner. You need to write u and column vector notation. That is not necessary. This is your own job to write a vector in this fashion or in that fashion or in ordered pair or in ordered triple notation. That is your own headache. But in your book the vectors are represented in column vector notation. So find this thing, that thing and that thing as well. I think these questions will be simple to solve. Now in this slide we will be studying about a number which is a negative number. If you multiply a negative number with a vector, so when a vector is multiplied by a negative number, it changes its direction. It changes its direction. If a vector a is in this direction and you multiply this vector by -1, so it will change the direction to that side. So that is the purpose of this first note. The second one is, if that scalar which is going to be multiplied, if that scalar lies between 0 and 1, how many numbers lying between 0 and 1? There are infinitely many numbers between 0 and 1. 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 10, 1 by 100, 1 by 10,000, 2 by 3, 2 by 5. Upstairs is numerator is less than denominator. That is that number will be lied between 0 and 1. So if the scalar lies between 0 and 1, then it reduces the length of the vector. It reduces the length of the vector. It shortens the vector. And thirdly, other scalars excluding 0 and 1 and between 0 and 1, other scalar numbers, for example, after 1 there is 2, 3, 4, 5, 6 and before 0 there is -1, -2, -3 and so on and so on. So all those numbers when multiplied by a vector, so that will increase the length of that vector. If the scalar is positive, so that the direction will be unchanged, but if that scalar is negative, so it will change the direction of the vector. Just look at this figure. You see, this is a vector a, that is a vector a, this is the length of vector a. The direction of this a is towards that side. This is the arrow, that is the head of this vector, or terminal point of this vector, head of this vector, terminal point. And this is the tail of this vector, or initial point of this vector. So this vector a having direction in that side. If you multiply this vector by a negative sign, just look at this negative sign, it changes the direction of a. That is now from b to this side, changes the direction of the vector. And just look at this thing, this whole is vector a. When you multiply this vector a by 3 by 4, you see 3 by 4 is a number which lies between 0 and 1. If you divide 3 by 4, you will get 0.75. 0.75 lies between 0 and 1. So this number lies between 0 and 1, so it will shorten this vector a. It will decrease, reduce the length of the vector. So you see, the length of the vector is this one, that is the length of this vector. But the length of 3 by 4a, just look at this thing, from here up to there. So this vector is shortened in this case because this is multiplied by a number which lies between 0 and 1, and because this number is positive, so the direction is the same as the direction of A. The direction is the same as the direction of A. If that was minus 3 by 4, so we'll put this direction here just like that. Anyways, so that is 3 by 4A. And just look at this vector. There is a huge vector. This is 2 times A. 2 is multiplied with this A, so it will increase the size of this vector 2 times. And because 2 is positive, so the direction of A is unchanged. The direction of 2A is unchanged, the same direction. So this is the geometrical representation of these hints which are given to you people. Now there are some other notes. The first one is 2D plane. What is a 2D plane? The plane produced from all ordered pairs x comma y is a 2D plane. If you look at the wall in front of you, so that wall is 2D wall because that is made from x-axis and y-axis. Just look at this thing. That is the x-axis. You are familiar with this line, and this is the y-axis. And this portion is called the first quadrant. That is the second one, that is the third one, and that is the fourth one. If you want to plot x comma y, so how could we? 1 comma 2, we will take 1 unit along x-axis and 2 units along y-axis, and combine these two to get 1 comma 2. So in first quadrant, all ordered pairs have positive components. X is positive and y is also positive. And the second quadrant, you see, if you want to plot -1 comma 2, so we will take -1 on the x-axis and 2 in the y-axis, so that is -1 comma 2. So in the second quadrant, x is negative and y is positive. If you want to plot -1 -2, so we'll go -1 along x-axis and we'll go -2 along, that is -2 along y-axis, and this -2, that -1 joins here, so that is -1 comma -2. You see, in the third quadrant, all x's are negative and all y's are negative. And in the fourth quadrant, if you want to plot 1 comma -2, so we'll go along x-axis 1 unit and we'll go along y-axis -2 units, that is -2, so that is 1 comma -2. And we see that in the fourth quadrant, x is positive and y is negative. So remember that the signs of x and y are in this fashion in different quadrants. Now, geometrical representation of addition and subtraction of vectors. We have studied recently that how could we find the sum and difference of two vectors. Now, what is the geometrical representation if you want to plot the addition of two vectors, the subtraction of two vectors? That is called the geometric representation of addition and subtraction. So first of all, you need to draw the position vector. What is the position vector? We have studied in the previous slide that position vector is actually drawn from the origin to the point in the plane or space. So draw the position vector of each point and complete the parallelogram by drawing parallel vectors to both the position vectors. So that is the first thing to do. Secondly, the diagonal from the origin, the diagonal from the origin of the parallelogram thus obtained is the addition of both the position vectors. And thirdly, for subtraction, if you want to subtract the two vectors, that is for addition of two vectors. If you want to subtract the two vectors, find the negative of the second vector. How could you find the negative of the second vector? Just multiply the vector by negative sign, so it will changes the direction of that vector. So find the negative of the second vector and complete the parallelogram so that the diagonal is the difference of both the vectors. So what all these 3 points, what about all these 3 points we will discuss here in this example. For example, you are asked to find v plus w, where v is a vector 4 2 and w is a vector minus 1 2, and also you need to find v minus w, the addition of these two vectors and the subtraction of these two vectors, and then you need to show v plus w and v minus w graphically. So there are two parts of this question. We need to find the sum and difference of v and w, and then we will show this sum and this difference graphically. So let us solve the solution. First of all, we need to find v plus w. V plus w means this v plus this w. How could we add these two vectors? You are familiar with this topic, that is 3 4, and the difference of these two is the same as sum, just you need to replace plus by negative sign. So v minus w, this is v, this is minus, this is w, so that is 5 0. So the sum of these two is 3 4 and the difference of these two is 5 0. Now how could we show this sum graphically? So that is the hint. Draw the position vector of each point. You can consider this v 4 comma 2, 4 comma 2, 4 comma 2, because this is x and this is y. X is positive, y is positive. So take 4 along x-axis, 1 2 3 4, and take 2 along y-axis, 1 2, and join them here. So this point is 4 2, this point is 4 2. So draw a vector from the origin to that point is the position vector of 4 2, which is actually v. So v is equal to 4 comma 2. Similarly, w minus 1 comma 2, along x-axis we will take minus 1 unit, so from this side that is minus 1, and along y-axis we will take 2, so 1 2. Combining this 2 along with this minus 1, this is the point minus 1 2. And if we draw a vector from origin to this point, so this vector is actually this w vector, that vector w is minus 1 2. Now secondly, the diagonal from the origin of the parallelogram thus obtained is the addition. What is a parallelogram? How could we draw? That is discussed here. Complete the parallelogram by drawing parallel vectors to both the position vectors. Just look at this vector. We will draw a vector parallel to w here, this one, and we'll draw a vector parallel to this w. This is actually v vector. So if this is v vector, then this is again a v vector because the direction is the same, and that is w vector. So draw parallel vector to w. So if this is w vector, then this is also w vector. So these two parallel vectors meet at this point, so that is a parallelogram. That is a parallelogram. This is the diagonal of this parallelogram. This is also the diagonal of this parallelogram, but uh, uh, this diagonal is from the origin, and this diagonal is not from the origin. So the diagonal which is from the origin towards that corner is actually the sum of these two vectors, v plus w. So the second hint is this one. Now we need to draw v minus w. So that is the third one. For subtraction, find the negative of the second vector. You see, this v vector is the same, that is the v vector, and that is the w vector, but we need to find v minus w. So we'll find the negative of w. What is the negative of w? That is the same w but in opposite direction. That is, if that is minus 1 comma 2, so minus w will be plus 1 minus 2. Multiply negative sign with minus 1 and multiply negative sign with 2. So that will become plus 1 and that will become minus 2. So that is the vector minus w. So that is w minus w. That is a vector which is parallel to minus w, and this is a vector which is parallel to v, this vector. These two vectors join each other at this point. So this is the diagonal from the origin towards that point. So that is the position vector of v minus w. That is v minus w, and v minus w is 5 comma 0, because this length 1 2 3 4 5, this length is 5, and because this line is along x-axis, so along x-axis y will be 0. So this point is 5 comma 0. Similarly here, this point will be v plus w, and you see here that v plus w is equal to 3 4. So this point will be 3 comma 4. You can write this in this fashion, 3 4. So this is v plus w, this vector. Anyways, this idea can be extended to 3D vectors. 3D vector is impossible to draw in this slide, because that actually lies in a space, and space cannot be drawn on a 2D plane. So anyways, this idea can be extended to 3D vectors. Now just look at this slide. In this slide we will study about the linear combination of vectors. So what does it mean? What does we mean about linear combination of vectors? Let's say we are given 3 vectors, u, v and w, be 3 vectors. These 3 vectors may be 2D vectors. What does it mean? That these 3 vectors may lie in a plane. 2D is actually a plane, and 3D is space. So these 3 vectors may lie on a plane or may lie in the space, and A, B, C be 3 constants. Sorry, A, B, C. This is not 2. This is 3. A, B, C be 3 constants. So whenever we multiply this A, this B, this C with all these 3 vectors and add them, so that is the linear combination of these 3 vectors. For example, if I multiply A or B or C with one of these 3 vectors, for example, I am multiplying that A, which is a number actually, 2 3 4 5, whatever that number is. If I multiply this A with this u, so this is a linear combination of a single vector u. If you multiply B with u, so that is again a single linear combination. And if you want to multiply C with u. So this is again linear combination of single vector u, because we are using single vector. Secondly, if we multiply a and b with two vectors, say I multiply a with u and b with v, or I multiply b with w, but two vectors. If I take two vectors from there and multiply two constants and add them, so this is the linear combination of two vectors u and v. If I use here w, so that will be linear combination of u and w. If I replace u by w, so that is the linear combination of w and v. Anyways, number 3, if I take all these three vectors and multiply them with a, b, c and add them, so this is the linear combination of three vectors u, v and w. If you are given the fourth one, so that will be the linear combination of the fourth vectors. So this is called the linear combination. If we multiply a constant number with a vector, single vector, that is called a linear combination of a single vector. If I multiply the constants with the sum of two vectors, so that is called the linear combination of two vectors, that is the linear combination of three vectors, and so on and so on. Now fourth one is, what is the graphical representation of AU? If I multiply a constant number with a vector, if I multiply a constant number with a vector, so this combination fill a line, and the combination AU plus BV fill a plane. Line is actually a real line denoted by R, and plane is made of xy axis, that is a 2D plane, so we represent a 2D plane by R square. So the sum of two vectors, the linear combination of two vectors fill a plane. Remember that the linear combination of one vector fill a line, the linear combination of two vectors fill a plane, and the linear combination of three vectors fill a three-dimensional space. Three-dimensional space is denoted by R cube because of 3, and R cube is the whole space in which we are living. The whole space is denoted by R cube. So remember that linear combination of one vector fill a line, linear combination of two vectors fill a plane, and linear combination of three vectors fill a three-dimensional space. Now number 7, for A, B, C belongs to R. What does it mean? R is the set of real numbers. If I take three numbers, three real numbers A, B, C, the ordered pair A comma B belongs to R square. If I make ordered pair A comma B, so this A comma B will belongs to R square. And if I put all these three real numbers in bracket, so this is called ordered triple, and all other ordered triple that will lie in the space. Ordered triples lie in a space, ordered pairs lie in a plane, and the numbers lie on the real line. Remember that. So that is the second one. Just look at this thing. This is the idea of this filling. AU fill a line. If I multiply a number with a vector u, you see here in this figure that is in your book, a number c is multiplied with u. This is actually u vector from here up to there. This is u vector. This u vector is multiplied by c, and c is taken to be minus 1 by 2. C is minus 1 by 2. So it means that c is actually half of u vector with negative sign. So half of this u vector is somewhere here, and because of this negative sign it will change its direction in this way. So this is minus u by 2. So all these multiplication will fill this line. If you multiply a constant number with a vector, so either it increases the size of this vector or decreases the size of this vector. It means that it will lie in all on all this line. So on all this line, it means that CU fill this line. This is the meaning of the fourth one, that AU fill a line. Similarly, just look at this thing. That is vector U and that is vector V. Recently we have studied that if you want to find U plus V, that will be the diagonal here, U plus V, and in U plus V the coefficient of U is 1 and the coefficient of V is 1. So in that case C is 1 and D is 1. It will lie here. If you vary this C and this D, so this whole portion will be filled. If you take the negative of U, so this U will come over there and this plane will be filled. If you take the negative of U, that will be here and that will be here. It means that it will fill this plane. And if you take the negative of this vector and negative of this vector, it will fill this whole plane. So the linear combination of these two fill planes, this plane, that plane, that plane and that plane. So similarly, if you take three vectors, so those three vectors will fill the whole space, which is not possible to draw here. So that is the meaning of this combination. The fifth one, the combination of AU plus BV fill a plane. That is the geometrical meaning. Anyways, that is example. We are concerned with example to solve example. How could we solve examples? That is the major thing in this course, to solve the questions, to get marks and so on. So example number 1, example is find all linear combinations of these two vectors, V vector which is 1 1 0 and W vector which is 0 1 1. Remember that we recently studied that this vector can be written in column form 1 1 0 or in ijk notation 1i plus 1j plus 0k. Similarly, this vector can be written in column form 0 1 1 or in ij form. How could you write this vector in ij form? 0 into I plus 1 into j plus 1 into k. So you are given these two vectors and you need to find the linear combinations of these two vectors. That is the first part. So the linear combination of these two vectors is AV plus BW. Recently we have studied that AV plus BV is the linear combination of two vectors. What is A and what is B? We are not concerned with that because we are going to find all linear combinations. If you vary A, if you put A 1 2 3 or minus 1 minus 2 minus 3, similarly B, you will get many combinations, and this is the general combination AV plus BW. So remember that when you need to find the all linear combinations, you need to add these two vectors along with A and B, or you may write C and D here, whatever you want to use the constants, but A, B are feasible to write here. So AV plus BW, that is A and this is V, plus BW, this is B, BW. Now this is the scalar multiple of this vector, so multiply A inside, AA0, just look at that, AA0, plus multiply B inside, 0BB, 0BB, and add these two vectors. How could you add these two vectors? Add the first components, second components and third components. So that will be A plus 0 comma A plus B comma 0 plus B. A plus 0 is A, 0 plus B is B, so that is A comma A plus B comma B. This is the linear combination of v and w. Or you may write in column vector notation. You can write av plus bw in this fashion. A into v vector, write this v vector in the column notation, plus b, write this w vector in the column notation, multiply a inside because this is the scalar multiple, and multiply b inside to get these two vectors, and finally add these two to get the same vector. That is in row form and this is in column form. Both have the same meaning. You can do this question, you can solve this question in this fashion as well as in this fashion. Both are correct. So these are the required combinations of v and w. Then the other one is state whether the linear combination fill a line or plane or three-dimensional space. So av plus bw, how could we say about this thing? We just recently studied that the linear combination of two vectors fill a plane. So this is the linear combination of two vectors. So these linear combinations fill a plane. That is the answer for the second statement. I think this is very easy to solve and I hope you will understand this thing. Example number 2, that is find two equations for the unknowns c and d, so that the linear combination cv plus dw equal to the vector b. What does it mean? cv plus dw equals to b. Hence find c and d where v and w and b are given to you people. It means that you need to take equal this sum to b, cv plus dw is equal to b, and then you need to find the two equations and then find c and d. So anyways, the answer is we need to take cv plus dw is equal to b, so that is c into v, that is v, d into w, d into this w is equal to b, that is b. You can replace b here as well, but after simplification we will replace this b at the end. Now this is the scalar multiple of 2 minus 1, so multiply c inside, d inside to get these two vectors. Now adding these two vectors to get 2c plus minus minus d minus c plus 2d is equal to, now I am replacing b by 1 comma 0. Now comparing these two matrices, these two vectors, actually two vectors are equal if the corresponding entries are equal. I mean that first component equal to first component, second component equal to second component. So comparing both the vectors, you will get 2c minus d is equal to 1 and minus c plus 2d is equal to 0. So that is the first equation and that is the second equation. So this is the answer for the first part, that find two equations. So these are the two equations, and the second part is to find the value of c and d. How could you find the value of c and d from these two equations? You need to solve these two equations simultaneously. These are the required two equations. That is the answer for the first part. Now to find c and d, we solve equation 1 and 2 simultaneously. How could we solve these two equations? You can solve these two equations by multiplying this equation by 2 and then add these two to cancel out d to get c, and put c in this equation or in this equation to get d. That is the first one. And the second one is you can solve this system by substitution method. So from this equation, from equation 2, if you convert this minus c towards that side, so c is equal to 2d. So from equation 2, c is equal to 2d. Now put c, which is 2d, in equation number 1. So that is equation number 1, 2c minus d. Replace c by 2d, so that is 2d minus d is equal to 1. That is 4d minus d is equal to 1, and that is the value of d, which is 1 by 3. Now put this d here, r there whenever you want. Put c here, put d here to get the value of c. So c is equal to 2d, so there is 2 into this d, so there is 2 by 3. So this is the value of c, which is 2 by 3. So that is the end of this lecture, and I hope that you people will be happy to listen this lecture. If there is anything else to ask, to understand, kindly ask as quickly as possible, because after this lecture second lecture will be uploaded. So that's why I'm telling you people to ask questions as soon as possible.